everyone who's attending this session. This session is dedicated to the presentation of the water safety plan in region Friuli-Venezia Giulia. The title is Drinkable Water Network Resilience in a Regional Climate Change Framework. We know that climate change is posing a powerful challenge to water supply systems worldwide. This means increasing vulnerability to water scarcity, but not only that. Water management systems are threatened by extreme climate events in many ways. We shall learn how, and especially how we expect climate change will affect water management systems in this region. Water safety plan is a way to an increasingly diffused approach worldwide in order to increase the resilience and the capability of water management systems to get adapted using a forward-looking approach. We know that vulnerability to risk is highest when we are unprepared to risky events. So water safety plan is a way to get prepared in advance, to set priorities, to identify the risk forward, and therefore to have ready the actions that can reduce the impact of risky events. We can. The panel today is divided into groups. We have a first group which is represented by experts coming from the water companies that have dealt with very innovative plan in a cooperative way. That this means bringing together the experience of many different water operators into this common project. And then in the second part, we'll have a panel of water management specialists from the academy, from the university, that will give further insights and views. So I think that it is time to start. The first speaker in the first half of the session is Engineer Enrico Altran. He's head of the Startup New Plants and Program Management for AcegasaApsAmga, which is the water company in the city of Trieste, and he will provide in 5 minutes a short background of the water management situation in Friuli-Venezia Giulia. Thank you, Enrico.
Thank you, Antonio. Ten years ago, the General Assembly of the United Nations recognized the right to safe and clean drinking water and sanitation as a human right that is essential for the full enjoyment of the life and all human rights. Starting from this point, we have to speak today, and I just wish you the greetings also on behalf of AcegasaApsAmga CEO, Mr. Gasparetto. I wish you a fruitful meeting on drinkable water network resilience in a regional climate change framework. We will propose some experiences gained in our region that can be useful in addressing the problems that climate change causes in the water supply sector. Some information regarding our region. Our region is composed by 215 municipalities. There are 4 towns with more than 40,000 inhabitants. Total inhabitants at the end of last year was quite approximately about 1,215,000. There are 720,000 inhabitants citizens, 431 hilly, and 63,000 inhabitants in mountain areas. Totally, the 38% of citizens lives in urban areas. There are 7 utilities which provides the management of the water cycle. Drinkable water and wastewater management in Italy are regulated, and there is a national regulatory agency which carries out regulation and control activities in the electricity, natural gas, water services, water cycle, and remote heat sectors. This national authority faced to the regional regulatory agency, participated by the municipality of the region, which carries out planning, organization, and controlling activities on the management of the integrated water services. Under this regulatory service, there is the regulatory bodies. There are the utilities which operate on the basis of multi-year contracts, which require minimum quality standards of service to be respected, and the acceptance of multi-year industrial plans to be implemented relying on a tariff method that allow full coverage of costs. Each utility is organized autonomously according to its legal, financial, and operational nature. In our region, 6 utilities are owned by their municipalities: CAFC, Irisacqua, Poiana, LTA, Hydrogia, and Acquedotto del Carso. The 7th one is owned, called AcegasaApsAmga, is a multi-utility company entirely owned by ERA Group, a company listed on the Italian stock market, and mostly owned by private investors. Public shareholders keep a stake of 48% through a shareholder agreement. These different utilities must operate on the territory, taking into account geology, land use, structures, history and cultural differences, financial issues, but they understood how the problems to be faced transcend their respective administrative boundaries and decided to undertake a common bottom-up path to share their best practices and their economic and financial efforts by building a cooperation platform that we believe can be a useful example to address on a regional scale the problems that climate change has been presenting to us in the recent and in the future years. Now my colleagues will present you our efforts and our programs for the future years. Thank you for your attention.
Thank you very much, Enrico, also for keeping perfectly the allowed time schedule. I immediately shift the microphone to the next speaker, who's Engineer Furio Pillan. He's head of the Research and Development and Energy Management Unit at Irisacqua, which is the water company in the eastern part of the region, in the surroundings of Gorizia. And he shall present the first part of the approach to the water safety plan adopted here in Friuli. 10 minutes available to Furio. Thank you, Furio. The floor is yours.
Thank you, Antonio. As you can see, we are talking about water safety plan, and the topic is Friuli Venezia Giulia experience, a virtuous example of water safety plan implementation. Thank you also to Giada Saccavini that helped me from Hydrogia company to build this presentation. So first of all, what is a water safety plan? Water safety plans were introduced internationally in 2004 by the World Health Organization as a new model for management and quality control of water intended for human consumption. This is a new systematic approach to risk assessment and management in the water sector that includes all phases of drinking water supply chain from collection to the consumer. And the main purpose of World Health Organization is to protect the public health. Of course, we have an European directive and Italian law on this topic. And, but this point of view has been developed in Italy by Italian Institute of Health, introducing national guidelines and promoting a national training system. As you can see with guideline ISTISAN 1421. What is new about water safety plan? In drinking water management, we are used to apply a retrospective approach that can be summarized in the expression run and repair. Now we are moving to a new approach in which the team of experts work together to prevent failures, and we can call them proactive approach. We can summarize the expression like analyze, think, prevent, act. So it's quite different. Water safety plan is a holistic point of view, a data evaluation-based plan that can help to elaborate prediction concerning failures of drinking water system, dealing with both water quality, for example, natural and anthropogenic pressures, but also water quantity, inefficient use, and climate change. And all under a scientific point of view, a scientific approach based on data analysis, risk management, hydraulic models, hydrological forecasts, and essential cooperation with universities and environmental stakeholders. In Friuli Venezia Giulia, we were able to understand the importance and complexity of the work. So why not do it together? Why not to share our expert abilities and experience for a common goal? It could be an efficient way to save human resource. The answer was in June 2018. The agreement was signed by the 7 water management companies and the analytical lab, Friul Lab and Aerotech. And we think that with a common approach, the plans will be comparables in our region, and this is quite an important thing. And by working together and sharing information and models, we are able to face climate change from a common resilience perspective. So we decided to work on something particular, so the plan of safety plans. And then if we need a team of experts to build a water safety plan, to build a plan of safety plan, we need a team of teams. And this has been a very important experience from a human point of view, but also professional point of view. So we involved more than 30 people from different companies in 6 working teams, each of them specialized in a particular topic. As you can see, adduction distribution team, treatment team, water collection team, analytical chemistry team, SCADA team, and all coordinated from methodological team. In the Friuli Venezia Giulia model represents a unique application at the moment of the Italian guidelines on a regional scale, with the aim of creating a virtuous, collaborative, and comparable system among all the entities involved. The plan is shared with the Regione Friuli Venezia Giulia, Central Directorate for Health, Social Policies and Disabilities, Regional Agency for Environmental and Protection, Regional Authority of Water Service and Waste, and of course the 7 the regional water companies. And of course we have also stakeholders participation, other stakeholders participation, of course users, municipalities, and other kind of water management company. Another important goal that we have to achieve is water safety plan could be land use planning instrument, and this is another new thing. Which are the results? First of all, a common methodological evaluation for all our region, characterized by extensive list of hazards. We found more than 1,000 different hazards in our system, so it's quite tough work. Useful system of determining the rate for events, a common database and a common cloud, and a real water system application. At this moment, the results of this work after 2 years are that you can see. So what about risk analysis and climate change? Risk analysis pushes us to monitor the effects of climate change on the drinking water system by measuring, for example, the seasonal trend of the year-to-year groundwater level. Risk analysis and related investments allow us to optimize water collection with the aim of reducing water waste and monitoring the anthropogenic activities in the proximity of the collection to preserve the quality of the water waste. Raise awareness among stakeholders on the sustainable use of water. We can ask ourselves if climate change is already connected with water management and water safety plan in particular. Let me introduce a real event. On October 2018, a very powerful storm invested northeast of Italy and Barcis Lake, as you can see in the slide. The storm, named Vaia, was related to abnormal hot air for late October and climate change in this area. 8.6 million cubic meters of fellet timber filled up the lake, which is unfortunately a superficial collection for Hydrogea, a partner of our project. After a few months of timber persistence in the lake, water has been contaminated from an unknown chemical, and the users refused it for several days for the bad flavor and smell, even if chemical parameters were okay. This event led to a very interesting discussion between us about the rate of this kind of events and how to manage them in the risk assessment system. The main goals are the cooperation is deeply increasing the knowledge of drinking water-related phenomena in this area. We are collecting data together. We analyze climate change-related events by a scientific, holistic, and experience-based approach. And we work together for an aware future of drinking water management. This year, apart from COVID delay, we are going to complete the common methodological approach and apply it to 10 real water systems. We hope that our virtuous point of view could be an example for the Italian and foreign regions for water safety plan implementation. Thank you.
Okay, thank you, Furio. You saved 1 minute nearly, so I thank you also for this. And I can immediately give the floor to Ingegnere Annalisa Pinzano, who's the next speaker. As we have learned, the companies involved in this project are 7. We have only 3 now here. The third one is Kafka, the water utility of operating in the area of Udine. Annalisa is coordinator of the operational division of the water supply service, and her speech deals with the more in detail with the process of developing and implementing the master plan for water safety. Annalisa, the floor is yours. 10 minutes as usual.
Thank you, Antonio. Hello, everyone. Now I speak about the process of developing and implementing the master plan. What are the best practices? The regional companies of the integrated water service, following a meeting with the Friuli-Venezia Giulia region and ASER, proposed the management of the master plan section in a shared form through the establishment of a temporary business grouping. A group was formed with one member for each of the 7 managers. We are currently preparing the specification for the MPA drafting assignment. We are setting up an experiment on regional scale, something concrete to be taken together. The FVG region is rich in water. The sources of appropriation came mainly from wells and partially from surface sources. The lowering of the groundwater caused by the progressive desertification of the territory affects the quantity of water, while the frequent and intense rains pollute the springs and create a water quality problem. Water scarcity, groundwater recharge, loss reduction, new supply sources. It is necessary to draw up a new plan with a strategic vision that will allow us to meet these needs. The objective of the Aqueduct Master Plan is to identify a planned strategic intervention aimed at ensuring a progressive and effective implementation of connections between the various aqueduct systems of the region, as well as with the interregional and international homes. The current structure prevents the adoption of measures to mitigate the impacts of any water crisis on individual water basins. Therefore, the total or limited unavailability of the source determines condition of unavailability of the resource through the underlying aqueduct system. The managers of the region have therefore decided to develop a new project to connect their respective systems together, also included a study of possible connection with the aqueduct system across the border. This project aims at significant increase in the resilience of the regional aqueduct system. We need to change the way we think about master plans and the master planning process used in the past by changing the way we have traditionally developed our master plan and how we keep them up to date. When a master plan is developed, it's an opportunity to engage stakeholders and the public to elevate strategic planning. Engaging the right stakeholders can lead to more efficient and informed decision-making, and as a result, a more sustainable, comprehensive and usable master plan. Which are the aspects of a master planning deal with? Some of the assets and organizational uses often addressed in the master plan include tanks, treatment plants, distribution system, financial impacts, and pricing. A master plan should reflect a vision and include a strategic plan to achieve the vision of a specific time period. Stakeholders should work together to make decisions using the data generated by their respective areas, and all of this helps change the use of plan into a dynamic decision-making tools. So, the best practices approach showed that when developing or updating a master plan, a range of data inputs must be considered. Some of these inputs are documents that already exist at the manager services and can be developed specifically for the master plan. The master plan is a continuous process, cyclically and integrated, divided in 2 phases. The first is data inputs. And which are data inputs? Strategic direction. Make sure that the master plan supports the vision. Finance information. It's necessary to identify cost of providing the service. Asset information. Determine their residual life and highlighting their criticalities. Projection on the population, trends, land use, driving rules, and the last, stakeholders and public communication. It's necessary to develop a communication strategy with interested parties. Sorry. The second phase regards the stages of master planning. The master planning steps described in figure are aimed at asset public service and identifying the main activities to be carried out over time to maintain a dynamic and update master plan. These steps are recommended during the initial development of the master plan as an ongoing process to ensure that the master plan reflects current decisions. Some of these are identify the reasons of developing the master plan, collect data, analyze the data, and for this aspect, it's necessary to cooperate with the university, which can provide scientific support to elaborate and deepen these uses with demand modeling systems. It is also important to involve demand forecasting professionals, economics engineers, database specialists. The first steps of the 7 is identify options for providing a service that support anticipated growth and development and meet service levels and strategic goals. Options might include, will be necessary to build lines to meet demand. It is possible to take the water from another operator. It is possible to convert an industry with high water use into a process that uses less or not water. Can maintenance be improved? These are some examples. The other steps we can view in the figure. At the last, it's important the management of monitoring of programs. In this phase, the objective of the master plan are identified. Using KPI can track progress in achieving the goals of the master plan. So the preparation of this complex document requires the presence of various professional figures who must collaborate synergically with their water service managers. The plan document must have a vision of approximately 30-40 years with the ongoing cyclical review process. The resilience of the drinking water system is essential to ensure the safety of the reservoir, which has been severely tested by numerous climate change and man's anthropogenic actions. Thanks for attention.
Thank you, Annalisa. Sorry, I see the screen here. Something happened. Okay. Thank you also for saving 1 minute. Okay, this first session, as I promised, gave us a presentation of the structure and approach used in the water safety planning in Friuli Venezia Giulia through the cooperative effort of the 7 operators. Now we move to the second half, to the second part of this panel. It is composed by 4 experts coming from the academy. The first one is Isabella Velicogna. She will talk to us directly from California. She's professor of Earth System Sciences and also Associate Dean of Graduate Studies, Equity and Inclusion School in the School of Physical Science in the Department of Earth System Science in the University of California. Again, Isabella, 10 minutes time for you, and the floor is yours, please.
Thank you, Antonio. So today I wanted to talk to you about major opportunities that I think we have now. It is newly available for making informed decision for what is concerning water management and issue related, and this opportunity involved combining climate model and remote sensing observation. Climate change and human activity are a very strong impact on water resources. We are observing not everywhere across the world, but in many places. And so decision making has to account for this. So it's important to being able to do this in the most effective way, both from the cost and again, the practical point of view. So remote sensing and camera combined with climate model can really help to do this. They are a very unique tool, and I hope that I'm going to give you, I try to convince partially that, you know, this is really something that is really needed now and really offer an opportunity to make decision about water resources and component of the entire water cycle, and all those factors contribute again to being available, you know, impact the water quality and water availability. So remote sensing, one of the key things about remote sensing is that it does not know political boundary. Data, there is an abundance of public data, and those data are global, so are available everywhere. And they're going to be available. I think now we are what I would call the golden age of remote sensing. We have this a series of information and satellite that provide really some incredible data sets. Modeling are becoming more and more reliable. They have a better physical processes, and they're also becoming better and better in migrating to global and you know, larger scale to higher spatial resolution. So what we are now, you know, we are in a stage where we can connect the global scale to the local scale, and what to make, you know, to use this in an effective way and really make strong process. We want to, you know, make sure to, we need investment in terms of research. We need to involve experts. While, you know, there are a lot of products that are available, it's very important, especially to make informed decision and to have a robust risk assessment and cost assessment, to be able to have experts dealing with this, the informed science. And then it's key more and more the connectivity between science and stakeholder. I think the scientists are trying more and more to look at the output of the science in terms of how we can generate product and information to make decision. So this, you know, operating this world is going to be really, I think, critical to contribute to define, you know, environmental, social, and governance criteria. They are more and more used to evaluate, again, if you want to bridge, also look at the company and investment. And so this is really a great opportunity. So the idea is we want to build a decision network that is informed by remote sensing models for stakeholders, and include also point observation and ground observation. The idea is that we put together those observation and model, and we use this to together with, you know, we use this to highlight important changes and alert stakeholders, and being able to, you know, trigger action where needed and if needed, and add information for when those actions again can be needed in the future. So on the and that's again is going to be, you know, a loop. The cartoon on the left just kind of represent this, and so on your right you can see there is a, you know, we're talking about bridging across different scale. We go from observation that can have at the scale of 100 kilometers, hundreds of kilometers, to other observation for satellite that come from tens of the kilometer, and to the really local scale. So we can talk about well ground observation. So how we plan, you know, the idea is that to use a machine learning approach, some, you know, approaches like machine learning and spatial by, you know, and temporal Bayesian analysis, so that we can combine this data to observe and monitor, you know, the evolution of the water resources and the different components, but also have uncertainty associated. They're gonna help us to make an assessment. I'm gonna show you some example of, here, this is a movie that it shows you, this is a drought severity index. Drought severity index are a very convenient metric when we want to monitor drought and availability of water resources. Generally, drought is severity index where, the most common one use information related to precipitation or surface water. Since 2002, we have some satellite data that provide information about the total water column, like information about also the groundwater. And so we can build some metric that allowed us to monitor those changes. And this is like, again, information from space, and we can see how the evolution of the water resources. And we have uncertainty associated to this. This is another example. So we can zoom in before I show you a global view. Now we can, I want to look at give you an example of what I mean when we say we are looking at different aspects. So this is the United States, and on the left you can see there are like 3 different drought severity index. They're basically those metrics that we use for monitoring. The PDSI, so the 2 on the right are really more sensitive to surface water. They don't have a lot of information about groundwater and water storage in the ground. While the one base of those satellite observation has information about water content in the ground. As you see, so a good example to see what is the additional capability that we get in this sense is like, if we look at the map of the United States, this is a correlation between the 2 indexes that shows how they correlate, this is during a specific, during the period of the analysis. And I want to just point out, if you see the drought severity index that is more related to the surface water availability, really match, very well with soil moisture. We give information about the top few centimeters, but it doesn't capture the fact that, what is the variability of the deep water content in the soil. While this other data, which now they're represented as the, I call it gray drought severity index, are really correlated, really showing what happened at depth. And the blue line is that measurement from well of groundwater. You can see we find a very good agreement. The idea is like we can put together this capability and really use that in a synergistic approach. Here's another example, and I'm going to browse quickly through this, that shows an example for Europe. And again, you can highlight, you can use this data to monitor some major drought that occur in 2003, 2006, and across Europe. Okay, so that was one tool, and this I want to show you an example of how this tool can be used to making decisions. This is an example for the Indus Basin. The Indus Basin is a very highly populated area, is at the boundary of Pakistan, India, and is an area where there's a large uncertainty in what is happening, and I want to show you an example of some work that's been done to monitor what are the changes in water storage in the upper Indus Basin, and how we can use observation together with model to evaluate what are the model that work better, what are the performance. So all those time series that you see on the left is a comparison between observation of water storage variability from observation, which are the black line, and different model. And you can see there's some models that don't really perform very well. And so we can highlight what are the best models, and those models we can use it to, again, select it and input it in our network, in the decision-making network. Another and more detailed example here, for example, this is a zoom, this is for the upper Indus Basin. In this case, we are looking, again, we can evaluate the model, but also the component of the water cycle. And so in this case, we can see clearly that in one case, the model, we have one model that is operating very well. On the left, this is a global climate model from NOAA in the US. And on the right, there is another climate model, is the NASA climate model, which is performing not very well. And the reason is that this is a very challenging region because due to the high orography. And so this is an easy way to evaluate. And so we select the best model and we use this data to input in the network. Okay, the last example I want to show you is how we can use this data to evaluate the impact of action that we are doing on the environment. So one very common approach to mitigate greenhouse gas emission and to also curb the land degradation is what is called ecological restoration. It's done in different ways. this is an example of evaluating the impact that the ecological restoration has in China. And we're looking at the area in central China, and has been ongoing for decades, this project of re-greening. And what we observed, we found, and we were able to do this using satellite data, that why the water storage was increasing before the intervention. After the intervention, we find a significant depletion of water resources in this area. And the impact of this is that we can use this to provide information about what is the, the impact, what is the impact of operation they were doing, or the intervention they were doing on the soil, and this was not available. And the thing is that in this area, this is a surprise. It was not expected to have an impact on the water resources locally. So I just want to conclude. These are just some examples. I think that we are at the eve of a major transformation on how to manage decision making for water resources. And it is really, we are in a very key phase. I think there is a great opportunity to invest resources in research and working with, in connection with policymakers and stakeholders to be able to effectively use and exploit this data.
Okay, thank you very much. Thank you very much, Isabella, for this very interesting presentation. We go back now to the main room. The next two speakers are from my own university, from the University of Udine. We shall start with Dottoressa Elisa Arnone. She's assistant professor at the department at the Polytechnic Department of Engineering and Architecture here in the University of Udine. Elisa, the floor is yours. Again, 10 minutes available.
All right, thank you, Dr. Massaruto, for your introduction. Good morning, everybody, for being here. So, well, my contribution here was just to give a very small or limited overview or some insights on what hydrological science can provide to people who, at the end of the story, have to make decisions. So I'm not going to stress further the fact that alterations in climate are underway. We've been experiencing extreme events that are becoming even more extremes, both in terms of floods or droughts or even heat waves. And so, of course, all these alterations have impacts, have implication on the water cycle, and then in the end on the estimation of the water availability, the fresh water. Mainly because the increasing volatility of the two main variable, temperatures and precipitation, change each component of the entire hydrological water balance. So, of course, there are some challenges. I just listed here two of them. So the challenge that water utilities or engineers has to face up, some of them are managing water resources in a condition of no stationary climate, and then designing or even make verification of existing hydraulic infrastructures in a resilient way. But science, luckily, has been developing in the last decades many approaches, many methodologies that can be used also in operational processes. So I'm going here in the next few minutes to give you an overview on what is, based on my experience, based on my studies, what hydrological science can provide. And most of these approaches are based on, is this working? No. Most of these approaches are based on the use of projections and predictions that comes from the global climate models. So the global climate models, my colleague was telling before that models luckily are going to be better and better, and this is true, luckily. And so climate model simply are numerical models that simulate the very complex climate system, and then that divide the entire globe in a regular grid, very big grid, and then within each grid, in the end, these models are able to provide us with the main meteorological variables in terms of climate projections, so in terms of response of the climate system to a specific scenario of future emission, for example. Well, of course, the use of such products is not that easy. I mean, those products, we cannot use like directly such products. We have to apply some techniques that are listed here, such as Bayer correction, downscaling in time and space, and so on. But even these techniques are becoming better and better in the years. But let's see how we can use such products and how can be used by also the water utilities in the operational processes. So here is an example. Well, when engineers have to design a generic hydrological structure, we use the depth, duration, frequency curve to identify the critical event. And then, so this curve derived from the analysis of the extreme historical data under the hypothesis of stationarity. So what happens if this hypothesis is not longer viable? Well, this is what, for example, we studied in a case study that was carried out in Sicily, where we used the Euro-coded models, a multimodal ensemble of the Euro-coded models. So we analyzed the impact of climate change on sub-daily extreme precipitation, given that the short duration, as we know, normally are the most extreme. And then we ended up with those results. What are these results? These are some results for the two main metropolitan areas of Sicily, Palermo and Catania. And these are the changes in the DDF curve for the horizon 2000 to 2015. So, for example, if we focus on one of these 100 years return period, let's focus on this. So this black line here is the historical DDF curve. So the one that engineers now use to design structures. What happened in 50 years, if in the most severe climate change scenario, is that this curve going up until this dashed line. So this means that an event, a critical event that now has a return period of 100 years, in 50 years, in the most severe scenario, will have an higher and higher return period. Another type of climate data that comes from the climate models are called seasonal forecast data. And these are data that are climate predictions for the upcoming, up to the 7 months in advance. What this data tell us? So today we are able to know how the next season will be in terms of anomalies in respect with the expected values. So we could know whether the next season will be drier or wetter. And of course, this information can be useful for the water manager, for who has to make decisions. So this is an example on how those kind of data can be used. This is a methodology that I developed with this company, Amigo Climate, again, to extract some information from the climate, from the seasonal forecast. This is an application for the drought alert. Of course, it can be used on the opposite by looking at the other side of the distributions for the weather. We propose and we test this methodology with a water utility company, with Sicilia Acque, to see whether we were able to predict some events that were very critical for them, for their water management, and that occurred in 2001 and 2016. And indeed, in some cases, we were able to predict with 3 months in advance the drought. Of course, in other cases, the system failed, of course. Well, I skipped this part because maybe I don't have time for this, because what I want to say to you is that from where we can get those data. These are open. This is a nice thing. The European Commission has promoted a very nice service called Copernicus Climate Change Services, the C3S, which is implemented by the European Center for Medium Range Weather Forecast, the ECMWF. And specifically, if you go to the Climate Data Store webpage, you can search and surf a lot of type of data for past, present, and future. So I don't know how I am with the time, but I go to the conclusions, well, some obvious conclusions. Just to say that hydrological, well, science in general has been developing very interesting methodologies, and it is also interesting to see how the company wants, sometimes they ask for methodology to be applied in their processes. And at this regard, I underline and highlight also that it is very important, to my opinion, a so-called co-design process with a water company, with the final end user, to improve the methodology itself and also to improve the know-how. So, of course, collaboration are always welcome from our side. Thank you.
Okay. Thank you. Thank you, Elisa, for this for your very interesting presentation. Okay, now the next presentation will be held by Matteo Nicolini. Matteo is also an assistant professor of hydraulic structures at the University of Udine. Matteo, I give the floor immediately to you, and you have 10 minutes at your disposition as the others. Please.
Okay. Thank you, Antonio. Good morning to everybody. In this presentation, I will talk about multi-objective optimization in planning and in the management of water distribution systems. And in particular, putting into evidence the fact that they are related to very different time horizons. Mid to long term on one side, and short term on the other. Then we show a couple of examples of a methodology that we have developed in these last years in order to approach and solve such problems. Well, first of all, when we talk about mid to long term, you see on the left part of the slide that we are dealing with water distribution optimal planning and design, in particular with strategic master plans we have listened before. or optimal CAPEX, capital expenditures prioritization. When we talk about short term, we are dealing with network operation maintenance. And one of the most important issues here is the problem of leakages, we saw also in our system. So the leakage reduction problem is one of the main problems of short-term optimization. Then, of course, water quality issues is another problem for water safety plans and countermeasures. And networks, maintenance, and real-time operations is another class of problems for short-term optimization. We show that utilities can save, you see, at least 15% or even more of OPEX, operational expenditure, and CAPEX by implementing innovative solutions, methodologies, approaches. We are now applying a lot of application methodologies coming from big data analytics, machine learning, from artificial intelligence, and also from complex network theory. But I will show in the next slide just a couple of examples of the methodology. The approach we have developed is called the simulation optimization approach. It's well consolidated now. And I will start saying that decision makers are concerned with two main issues. You see, to achieve a good level of compromise between conflicting criteria, conflicting objectives: cost, performance, reliability, resilience, and to maintain a desired level, a desired use of resources compatible with the environment, available limits. Sustainability is an issue, especially in a context of, we have seen, climate change. So the objective of research was to implement such an approach in order to optimize such systems under this condition through a synergy, a coupling between an optimizer, general multi-objective optimizer based on evolutionary algorithms, which is a part of soft computing and machine learning from artificial intelligence, and of course an hydraulic network solver. We can solve a lot of problems. This is a list. You see the planning and design of a new water distribution system or rehabilitate an existing system. They are very similar problems in the context, for example, of a master plan. The subdivision of a system in DMAs, district metered areas, also this is another example. Performing pressure management for leak reduction. And also the short-term optimization of pump operations, also with the real-time controller by PLC. Now we are working also on the location of surge relief valves to avoid transients and their negative effects on long pipelines. Every problem can be recast, formulated like an optimization, multi-objective optimization problem analytically, characterized by at least two objective functions, constraints, decision variables, and of course, parameters. So you see a couple of examples here. On the left, the problem of design with two objectives. We'll see them in the next slide. In the right part of the slide, you see the pressure management problem. We will see them. So, as an example, take a general system. We want to design or rehabilitate in order to have a network more resilient, more performant, but with the constraint of minimizing costs. We can think about two objectives, two conflicting objectives. Minimization of costs, in red, the objective function, and the maximization of performance in terms of resilience, for example, of reliability. What is the solution that these algorithms give us? This is, for example, the interface of the software we have developed. And the solution, you see, is not a unique solution. Typically is a set of solutions. This is very typical of multi-objective problems. If you have two objectives, two conflicting objectives, the Pareto set represents the optimal solutions. All of them are equally optimal. The colored circles that you see in the right part of the slide represent all the optimal solution of this problem. From the least cost in the lower left, the red circle, up to the most expensive but also very resilient solution, the blue one. In the context of decision making, then the stakeholders or the decision makers will decide, will pick one solution, which means one network optimized, and then implement it in the real world. This is a part of the regional water system that has been investigating for years by our research group. In blue you see the network, the water distribution network, but also in red you see the main irrigation system to which we are applying such methodologies. We have two provinces, Udine and Gorizia here, and you see some data in this slide. In particular, you see pipes. Pipes are at least 50-year-old in the 70% of the cases. And some other data. Of all the produced water, 50% is no-revenue water on average, and water losses, real water leakages are nearly 40%. So one of the main issues that we can solve for the short term is how can you reduce leakage in the system. And this can be formulated as a two-objective optimization problem. You see in the plot, in the abscissa, we can put one objective function, which is the water leakage to be minimized. In the ordinate, you see the other objective function, the number of valves. It is a surrogate of costs to be installed in the system, pressure-reducing valves, in order to keep the pressure down and to save water. Typically, the starting situation of water distribution is the blue circle in the lower right part of the plot. There is no valves, and there is a lot of leakage. The Pareto front in this case is the set of colored circles representing 1, 2, 3, 4, and then valves, pressure-inducing valves installed in the system in order to reduce leakage. So this is also a frontier, a set which represents the different level of compromise between the competing objectives. And the algorithm gives this solution. For example, this is Gorizia, which has been the object of this installation. You see that beyond the valves, we can also define the district metered areas. So every colored circle of the plot before is here reported together with the zone, the area, controlled by at least one valve. So you can see there are 4 districts here, the yellow, the green, the red, and then magenta. And this methodology has been applied together with other algorithms to some cities and towns in our region. You see a list here. The codes represent the methodology, PRV, pressure-reducing valves, EMV, inverter, the remote control inverter for pump operation, then leakage, identification, repair, district metered areas, and so on. And what is the main message coming from this presentation? The results that one can achieve. This is a particular methodology, but there are other methodologies. You see the total length of such networks and the water and energy savings obtained by such methodology, actually obtained, measured. So we have more than 2,000 kilometers, and on average, you see the numbers we said before, 20, 25%, sometimes even more, not only of water, but if it is pump water, we can also save energy. I think that this general approach is very useful because we can face problems of very different time scales. We have seen short term, like these ones, but also mid to long term, like planning and design, like the master plan, which is going to be implemented in our region. I thank you very much for the attention.
Thank you. Thank you, Matteo. Okay, we have one last presentation to conclude the panel. In fact, this presentation will neither be made directly from the floor, nor from remote. It has been recorded previously by the colleague Professor Roberto Louven. He's a full professor of comparative public law at the University of Trieste, and the object of this speech is somewhat different from the previous ones. One key point in any planning process, but in this planning process in particular, is the way different stakeholders coordinate and interact together, and this presentation will be dedicated to this topic. I don't know if someone can run the movie, the MP4 file.
Good morning, everybody. Thank you very much for inviting me to this roundtable in Drinkable Water Network Resilience Initiative. Just a very short speech from my part, containing a few reflections on the involvement of stakeholders. Complex game, where stakeholders are people with an interest in this matter. Stakeholders are not people with economic interest, but also other kinds of interest. Business, of course, is important, it's fundamental, but around drinking water, we have to perceive the matter of a fair business. So, which kind of interests are we talking about? First of all, individual, human interests, not just in individual dimension, but also in communitarian dimension, because water, of course, is a vital necessity, and it is a human right. We have to remember and to underline this dimension, because this year we just celebrate the 10th anniversary of the United Nations Declaration about right to water and sanitation. Second, stakeholder, public entities, of course, with all their own articulations at each level. We have to consider water as a strategic factor of political, institutional stability, and at the same time, we have to consider the aim of prosperity of these states, these regions, these communities. Third stakeholder, of course, economic players in this sector, because we have a private, public and mixed management companies, and these kind of stakeholders are very, very directly concerned. Fourth stakeholder, I will name it big drinkers, agriculture, animal husbandry, breeding industry, and this kind of stakeholders have to be considered in the perspective also of a very recent and important regulation of European Union, just about the minimum requirements for the reuse of water. Number 5, stakeholders as association, as representative collective actions, class actions, and so on, for environmental issues, for economic and consumers protection. And then we have a kind of stone guest. We have always to remember that future generation exist or will soon exist, and they are older of biodiversity, resource interests at their time, which will soon arrive, and we hope they will find a water system in better condition than now. So we have always three poles in tension among them, because somebody called for water as a right, for the legal dimension of water rights. Somebody is working and fighting for water as a commodity in the economic dimension. And then we have another growing interest and growing attention to the ecological dimension, because environment and climate issues are particularly critical at this time, as everybody knows. So we have to put that question in clear for avoiding the danger of a huge misunderstanding. Water is not just human need. What is not just a factual issue of access to the resource. Water is also, and at the same time, our particular collective and individual right. And so we have two opposite views of stakeholders. On one side, somebody considering we have not to let decide technicians, a too important question to be left to technicians, we often hear, and the other side of the moon, I should say, arguing that that's a too important matter to be left to the people in general to decide how and where to work together very, very quickly. We need to operate and to react in emergencies, but emergency management is just a part of the solution of the problem, and casual, sporadic occasions cannot lead to a systematic solution. Somewhere, and sometimes we have informal moments in unplanned situations promoted by some unions, by parties, by some meetup, and so on. That's always sporadic and casual solutions. I think three kind of dialogues can be settled in this moment. One is a contracted agreement. We have some example of this kind in Patto per l'acqua della Lombardia and some other regions, which tried to put all the stakeholders around the table, discussing and contracting some solutions. We have more institutional setting in some experience I consider very positive, very virtuous, like Berlin Water Charter, which led to the Berlin Water Manifesto some years ago. And then we have another approach, we should call it a French approach, by constituting permanent administrative bodies of consultation of management. Its name is Agence de l'eau in France. It's a kind of a branch of public administration, but with also a kind of parliament with all the stakeholders discussing and trying to find some common decision in the common interest. My own conclusion: we have to play cards up. We have to play open end. In this moment, we need clear rules, and for having clear principles, clear powers in a multi-level system, clear responsibilities and clean procedures. We need good laws. We need good laws about that, and we know how difficult that is in this moment, particularly in Italy, discussing about public water. We also need a clear mental map of all stakeholders, and the procedure for reaching this kind of objective is to create an engaging and creative methodology. We have to put aside fears and reticences, and to work together with all the stakeholders, and through a fair representation also the sixth stakeholder, the future generations. So for reaching a democratic and efficient decision-making circuit, we have to make an effort and to grasp, to catch opportunities. We have one of these opportunities very, very soon with the imminent European Union directive. The Parliament and European Council are discussing at this time on drinking water. That's the consequence of the popular, the citizen initiative Right to Water, and I consider this can be also for Italy and other countries a very, very good opportunity for playing together, for playing open end between all the stakeholders around the water question.
Okay, I thank Roberto, even if he cannot hear us. So thanks to the efficiency of our speakers, we have saved some minutes for the discussion. If there are no questions from the floor, I perhaps can react to some messages that I have received on the chat. For example, Carlo Radolovic from Milano says, this is perhaps to Furio Pilan and to the other colleagues. You mentioned the 1,000 types of hazards. Can you give us some concrete example of what you mean with them, and how the water safety plan approach can help dealing with them more effectively? I don't know if someone wishes to answer, to react to this question. Perhaps Furio.
Thank you for your question. When I say that we have found more than 1,000 hazards, I mean that in the work that takes 2 years till now, the observation of our system and imaging in a risk assessment mode of thinking with all the groups that maybe you can remember for the presentation, came out really more than 1,000 different kind of hazard that goes through. It's very difficult to make an example without the metrics that we use.
The Via storm, for example.
Yes, we can take the collection hazards like anthropogenic pressures, agriculture pressures, industrial pressures on the water quality, but also a lot of hazards that come from the managing system, like leakages or like reservoir failure, structural failure, hydrological movements of the ground that can make some problem to our wells, to our collection wells. SCADA problem. We are going more and more in a direction of remote sensoring. And this, if the remote sensor control our system, a failure of the remote sensor could make a problem in our system, and people should remain without water. So it's a very complex system, and maybe one day there will be the chance to explain more in a more detailed way this kind of work that we have made, but they are really more than 1,000, so very tough work.
Okay.
Thank you.
Thank you. Someone has something to add to this, or can we move to the next question? Quickly, since we have not more than 10 minutes left. Okay, I am an economist. I forgot to tell this at the beginning. So as an economist, I am very much interested in how water safety plan can help saving money. Matteo Nicolini made very interesting examples of this. As an economist, I would say that the resource that is more scarce in water resources management is in fact money. And not because water is a commodity, as someone fears, but because intervening in adapting the natural capital availability is very costly and requires very huge human efforts, either on the management side or on the structural side. So has the water safety plan already put in place some capability of setting priorities of intervention? So for example, you mentioned leakage as one of the most important topics, and you showed immediate responses to how can we reduce leakage given the existing structure of the system. But can the water safety plan approach also help us in prioritizing investments and helping us designing better and more resilient networks in the future, and so on? So in this case, I think that stakeholders' involvement is fundamental, since stakeholders are in fact those who pay for the water service, and we wish, if we wish to deliver to them good value for money, we need also to listen to the kind of priorities that stakeholders put forward. So my question again is, which kind of stakeholder involvement have you planned to adapt here? Okay, as I have understood, the interplay between water management companies, regional authorities, and so on is a very important first step in terms of stakeholder coordination. But listening to the people, as Roberto has reminded us, is also very important. So have you made steps in this direction maybe Enrico could try to answer, or anyone else?
Yes, yes, of course. Customers have been involved and are still involved in several ways and systems. We have associations of stakeholders which are, to say partner of us, it is too high ambition. But we believe, and we started some years ago to contact, to involve them, and now we see that a path has been done. It's a long stride, a long street to be done from now on, and we planned it, and we forecasted some steps which will be followed during the implementation of our plans.
Okay, thank you, Enrico. Are there some questions from the panel? Okay, so I can profit of this 3 minutes to say that Furio knows this very well, because we have worked together with Irisaco. In this case, we have made an experiment to investigate what are the feelings of the people towards the different contents, the different quality contents of the water service: environmental, safety, reliability, resilience, good taste of water, health protection, and so on. And we have obtained very interesting answers. For example, there seems to be a very good awareness of the customers concerning the readiness the preparedness to spend a bit more, 10 to 15 or 20 euros per family per year, for example, in order to achieve better and more reliable protection in terms of health care and in terms of safety of water supplies to citizens. And another very important point that emerges from this investigation is that people rank very high also the environmental dimension. That is, for example, the capability of bringing natural water systems to good ecological quality, and so on. Have you dealt with these aspects also in the water safety plan, or are you concerned now only on mostly on reliability and safety? I don't know who can answer a question like this. Hello, is there anybody there?
Thank you again. Well, we are not really ready to answer this question, because a scientific approach means that you have before data and make decisions about this, but we are really interested in how people feel our decision, our works. Stakeholders are fundamental in this kind of thing. And the work that we made together with Win and Antonio is on this kind of way. So when you, one of the sons of the water safety plan is the investment plan. So before deciding to spend the money, that money is of the people, of the customers, you have to use several different kind of instruments to decide. And one, of course, is a science approach. One is long-term designing. Another one is choosing between the different investment that came up from the water safety plan to make a priority system of this, because there is no money to make everything, and our goal is not to make everything, but to make an efficient use of people money. So I think that this is going in the second step that we are going to face probably in next year, and how to decide which are the most relevant investment that we are going to do, and how much money we are going to ask to our customers. So
Okay.
it's going to be done. Thank you.
Thank you. Okay, I think that our time is over. I hope I have just the time to thank everybody for attending this this session. Also, all the speakers for their very interesting speeches and very lively interaction. So thank you again. I can say goodbye to all of you and to the audience, those connected from remote and those in the floor, on behalf of the organizing committee and the speakers. Thank you and goodbye.